In this video, we are going to be using standardized scores, so from our standard normal distribution, to find the mean and standard deviation. There's a formula we need to know to standardize a score. So the standardized score, which is Z, is equal to X, our number, minus the mean divided by the standard deviation. So this is to standardize a score. It represents how many standard deviations something is away from the mean. So if I had a mean of 10 and a standard deviation of 2, and my value, my x, was 12, 12 minus 10 over 2 is 2 over 2, so 1. It's a z score of 1. It's 1 standard deviation away from the mean. So for a standard normal distribution, the mean is 0 and the standard deviation is 1. Let's look at this question. So a random variable x is normally distributed with a mean of 9, and we don't know the standard deviation, but given the probability that x is greater than 11 is 0.24, we need to find the standard deviation. So a quick sketch, our mean is at 9, and the probability greater than 11 is 0.24. So if the probability greater than 11 is 0.24, the probability that x is less than 11, the area to the left of 11, must be 1 minus 0.24, 0.76. So what we're going to do is we're going to find for our standard normal, for our z value, what is the value that has an area of 0.76. So our standard normal, remember, has a mean of 0, a standard deviation of 1. So in this case, for our standard normal, what is the value that's got an area of 0.76? So we can use the calculator and it will tell us this z value. So inverse normal, that's what we want. So we're in distribution, inverse normal, the area is 0.76, the standard deviation is 1, the mean is 0, so the value is 0.706. So our z value is 0.706. That's what is going to go into our formula. So our z value, 0.706, is equal to our x, which in this case is 11, minus the mean, which is 9, divided by the standard deviation. So we've only got one unknown in this, because we know our z value, we know our x, and we know the mean. So if we times by standard deviation, 0.706 times standard deviation is equal to 11 take away 9, which is 2. So standard deviation is 2 divided by our last answer. So go 2 divided by answer, and we get 2.83. So standard deviation is 2.83. And one question for you to try, see if you can give it a go. So again, we've got a normal distribution. We've been given the mean, which is 50, and we need to work out the standard deviation. The probability that x is less than 40 is 0.12. So 40 is here, the mean is 50, and this area is 0.12. We're going to standardize it. We're going to use our standard normal, and we're going to use the formula z equals x minus the mean divided by standard deviation. So that's our formula. If we use our standard normal, we can find our z value, because it's going to have a mean, the standard normal, the mean is 0, standard deviation is 1, and we know the area is 0.12. So we can use that to find z. So we go to distribution, inverse normal. Our area is 0.12, and our z value is negative 1.17. Negative 1.17 is our z. We're going to put it into the formula. So z equals x, which is 40, minus the mean, which is 50, divided by the standard deviation. So multiply by the standard deviation and divide by our z, and we'll get standard deviation by itself. So negative 10 over our last answer, it's 8.51. Another question, this time we have to find the mean. So we don't know the mean, but we know the standard deviation is 5. The probability x is greater than 30 is 0.12. So this small area here is 0.12. So the big area, less than 30, must be 0.88. So we can use our standard normal to find the z value for an area of 0.88. So back to inverse normal. The area is 0.88. It's a standard normal. And we get 1.17. So now we're going to put it into the formula. So 1.17 is x minus the mean divided by the standard deviation. So we're going to times by 5. Answer times 5. 5.87 is 30 minus the mean. So the mean must be 30. Take away the answer, which is 24.1. One for you to try. See if you can give this one a go. So we know standard deviation is 4. The probability x is greater than 45 is 0.15. So the probability of being less than 45 must be 0.85. We're going to use the standard normal to find z. So we're going to go to distribution, inverse normal. The area is 0.85 and z is 1.04. Put it into the formula. So z is x minus the mean divided by standard deviation. So times by 4. 4.15. 4.15 is 45 minus the mean, so plus the mean, take away 4.15, so 45 minus answer is 40.9. So the mean is 40.9. And another question, this time we're not given the mean or the standard deviation, and we need to work them both out. But we've got 2 bits of information. So the probability that x is greater than 21 is 0.1. So the probability x is less than 21 must be 0.9. The probability x is less than 12 is 0.2. So we're going to find a z value for both of these bits of information. And we'll get 2 formulas, which is going to make simultaneous equations. So we're going to go to our inverse normal. And for our standard normal, to find our z, 0.9. So z is 1.28. I'm going to store that as a. 1.28. So our formula is 1.28 equals x, which is 21, minus the mean divided by standard deviation. For 0.2, the area is 0.2, negative 0.84. Negative 0.84 equals x minus the mean divided by standard deviation. And I'll store that one as b. So now we've got 2 equations with 2 unknowns. They are simultaneous. If I times both by standard deviation, 1.28 times standard deviation equals 21 minus the mean, or 1.28 standard deviation plus the mean equals 21. And for the other one, negative 0.84 times standard deviation is 12 minus the mean, or negative 0.84 standard deviation plus the mean equals 12. So we can just solve these on our calculator. So if I go to equation, simultaneous, two unknowns, 1.28x plus 1y is 21, and negative 0.84x plus 1y equals 12. I should have probably used the save numbers on the calculator. I've got x, so standard deviation is 4.25, and 15.6 for the mean. Let me just check this. So if I change them to A and B, I get 4.24 and 15.6. Let's change that, 4.24, using the whole number. So they are the answers. One for you to try. Give it a go. So the probability x is greater than 25 is 0.05. So the probability x is less than 25 must be 0.95. So we're going to use 0.95 to find our z value. So for distribution, inverse normal, 0.95, our z value is 1.64. And I'll store that. For the other one, the probability x is less than 18 is 0.1. We get negative 1.28. Store that one as well. So now we can put them into the formulas. Z equals x minus the mean divided by standard deviation, and z equals x minus the mean divided by standard deviation. So two equations, two unknowns. We just need to solve them. So I'm going to multiply both of them by standard deviation. I'll get both the unknowns on the same side. Then I'll just use the calculator to solve them. We could just take one equation away from the other one as well. That would also solve them, but the calculator should be quicker. So simultaneous equation with two unknowns, and I've got my a plus 1, a times standard deviation plus the mean plus one of the means equals 25. And the one I saved is b times standard deviation plus the mean equals 18. So standard deviation is 2.39. And 21.1 for the mean.